Okay. Hello everyone. I would like to give this is a kind of maintainer trick talk about what we have done in the Kubernetes. And this topic is about what we have done about the batch workload in the Kubernetes. And this is the Klaus, and I'm the co-leader of SIG scheduling. And the other one. Yeah.
Hello. Hi, I'm Kevin Wang. I'm a Kubernetes contributor and currently also working on the Volcano project. Will be introduced in this session. Thank you.
Okay, that's great. Okay, before we talk about the batch workload, I think we need to, I'd like to say why we want to have such kind of a topic. And you know, when the Kubernetes, we already talk about several things about CI/CD, DevOps, microservice, several things like that. We try to run Redis, Tomcat, and MySQL in the Kubernetes, but all of that workload is a kind of service workload. It's a kind of a long-running workload, right? And recently, we will hear that most of the people try to run some computing workload, high-performance workload in the Kubernetes, such as TensorFlow, we have Spark, and maybe some Flink, and maybe some other framework here. But when they try to run such kind of workload in the Kubernetes, we found several gaps here. Now, the first one is all or nothing. For example, the green one is one job, and the blue is another job, and each box is a pod. So, for example, in the computing workload, such as the MPI and distributed training of AI workload, they need to get all resources together to run the job. Otherwise, they don't need, the job should be pending here. Because each pod needs to communicate or exchange data with each other. Otherwise, they cannot finish the job. So, there are two worst cases. Now, this one is some people going to get the two jobs will only get part of resource. They are going to wait to the other part work to get enough resources to start. So this is kind of deadlock. So that means the blue job only get only part of blue job start, and it's trying to wait another two pods to start, and but the resource is occupied by the green jobs. So they are waiting with each other forever. This is a deadlock, and the two jobs cannot be finished forever. They will going to be pending here, except you kill them or disable do something manually to handle that. Another one is that if the blue job get enough resources to start, but in the default scheduler, we continue to schedule the other two pods here. So the green pod will start here, but the green job will not running because the other pods are not start. They need to exchange the data with each other. The running pods are waiting for the others. They consume the resource, but they didn't do anything. Yes, they call it as busy waiting. Just have some loop, consume resource, and waiting for the others. I think this one is what we want. We want the job start one by one. We don't waste the resource, and the job can be make sure start one by one. Yeah. So the solution is that we are going to do the scheduling a group of pods. We will do scheduling by the group of pods. So either all of them get enough resource, or we don't give any resource to them. Yeah. And this is our test, or our test result based on this case. Now the first case is a job will with 2 PS workers and have 2 PS and 4 workers. This is a job with 6 pods to start together, and this is the first case. So every job can start or can finish in 24 minutes. The blue you can see that the blue one is we have a project, we have some solution for that. Another one is a KubeFlow based on the default scheduler. This is the second case is that we have two jobs here. Now the two jobs have there are going to be 2 PS and 4 workers for each job. This is the test result of busy waiting case, because some pods are running here, busy waiting the results and consume the results. And the third case is we submit 5 jobs here, and because you can see that I use a different color here, because only 2 of 5 are finished. And the other one didn't finish. We can make sure that they will not finish, because when we check in the next day, more than 20 hours, they are still pending here. Because each of the jobs should be finished in about half an hour, but the other 3 jobs didn't finish in 20 hours. So, the result is here, but the job cannot be finished. It's going to be a really bad case for the users. I think this is the all or nothing case. Basically we resolve the problem. The job finished one by one. But there is an issue that we still have some resources idle here, right? We at least have some resource for the other 2 pods. Yes, if we have a smaller job, what we can do, right? A better solution is that we should backfill the 2 smaller jobs to the idle resource to improve the resource utilization here. Yeah, but sorry. In the we have this feature is ongoing. We have a pull request about the overall implementation here, but when we also provide some plugin or provide some interface to the user to decide which small job should be backfill. Because as you know, if the small job take a really long time to finish, you should not backfill this one, because you will make sure the blue one, if the blue one finished in time or in a really short time, you will make sure some more idle resource here. Yeah. Another case is that if we try to backfill, and that's going to be worse for the green job, because we have smaller job one by one here, and we try to backfill one by one, and the green job didn't get a chance to start, right? There's going to be a kind of starvation. The green job cannot finish in time. Yeah. So for us, we tried to avoid such kind of case. Now the first one is we try when the simple implementation is that after one backfill, we will not backfill another smaller job. For example, after we backfill the first brown job, we will not backfill another the small one, this one. We will keep it idle here. We just try to improve the resource utilization by one step. But we still provide the callback here, so you can decide whether we should do another round of backfill or something like that. This feature is ongoing. We also have some discussion here. Yeah. Yeah. And, I think this is for the gap 1. And another is we have gap 2. The gap 2 is that some people, in the current default scheduler or in the current implementation, if we have 2 namespaces, we cannot sure which namespace get how many results, right? If one namespace can submit 100 pod and the other namespace only submit 1 or 2 pod, the first namespace get more chance to get all results, right? It's going to be, the scheduler cannot make sure that. But this is unfair to the both namespace because they have similar priority, have similar weight or something like that. So the target is that we would like to share resources between the two namespaces or more namespace in proportion, right? You can share half resource of cluster, and you should get another half of cluster. Yes, scheduler will have to do that. It depends of how many resource, how many pod you are submitted to the cluster. Yeah. So there is a proposal that we are going to support fair share by the namespace, right, across the namespace. For example, in the namespace submit the blue job, even he have lots of resource requirements there, but we only give him, for example, 3 CPU here, and we also give 4 CPU to the other namespace. Anyway, if all the green pods are finished, the blue one can get all the resources of the cluster because there are no other people to share resources with him. Yeah, so the fair share will, the fair share policy will support by the dominant resource fairness to share resources between the different namespaces. For now, we only support, cross namespace because we try to do something based on the tenants, but for now, the tenants working group didn't define what is a tenant. So for now, we support by the namespace for this part. And this is the second gap. And we also found another gap is that different in the upstream, the pod, for example, the job, deployment, daemon side, something, all of this kind of workload only support one pod template. But when you try to run batch workload, they also require multiple pod template. For example, for the distributed training, we need to have parameter server pod, and we need to have worker pod. The pod template may be different. The Docker image may be different. The resource requirement may be different. For worker, they try to use the GPU, but for parameter server, they try to use the CPU if this is enough. Another case is that for the if we try to run the MPI workload, we need to have an index because the MPI need to talk with each other by the ID. For example, 1, 2, 3, 4. They need to know how many workers are there so they can talk with each other. This is a kind of or reduce, which is used by the AI workload. Another requirement is that for distributed training or MPI workload, if one pod was failed, the whole job should be restarted because the calculation, the pod need to communicate each other, and if one pod was restarted, the data was lost, the community history was lost, so they have to restart the whole job if they didn't did any checkpoint in the cluster. So all of these features are required to run batch workload in the Kubernetes. Yeah, and there are lots of other requirements or there are other gaps. We have job management. I think there also have something to enhancement. We also need to support queue. This is really similar to the batch system. Yes, we also need to support preemption, job level preemption for this one. And we also support hardware topologic, such as network and accelerator, something like that. We are going to do that. Yeah. Based on this one, we are going to have a project to include to resolve all this kind of gap for this part. Yeah.
Okay, so this is what we recently working on. We have created a new project to leverage that. So in the above, you can see that we call it a domain framework. So like the first one is a kind of example of long-running workload, right? It's a WordPress, and also like Kubeflow, it's a kind of short-running workload and framework, and also Spark, and the last one is actually KubeGene. It's for genome sequencing framework. So basically, this kind of framework, they have actually similar requirement that they all do like deployment and installation for the other frameworks, and also they have their own concepts or CRDs to define the job or queue, and they also have some requirement for to the underlying layer, especially for like GAN scheduling. But that's as Klaus just introduced, that's not enough. So to fill the gap between the frameworks and the vanilla Kubernetes, we use Volcano to offer the advanced functionality. So we have a common job abstraction to serve all these frameworks, so they can manage map all their definition to the Volcano CRD. So then the user could be much easier to define how your framework can be deployed. And also we also introduced more advanced functionality, scheduling functionalities like fair share and GAN scheduling. And also the job management here is to reflect the common job CRD. And also for the suspend, we will later on try to have a end-to-end better integration on GPU and FPGA. And also in the end, the user can still just use KubeCon to do all the operations. So it's still kind of you know, a Kubernetes native experience with this project. Looking into more little bit details. So currently we have like the green box are the components of Volcano. So we have a scheduler. So currently it's QBatch, but we also have more advanced features will be added to this Volcano scheduler. And for the controllers, currently we have two. One is the common job abstraction, and another one is the queue, because for especially the high performance or batch workloads, you may have a tons of pod created, but you know, in the cluster there's only limited resources. You want to them just to have the pod first there, and when some of the pods complete, you can spin up the other pods in the queue. Okay, and for the Volcano control, it's a command line to manage the Volcano components lifecycle. So the policy in the Volcano scheduler will still be pluggable. So you can either depends on your which kind of workload you are using. You can enable DRF or priority between jobs, or GAN schedule may be more common among all the frameworks. And also Volcano controllers, as I said, currently we basically have the job controller and the queue controller. And the Volcanoes, in a nutshell, we want to make Volcano the best solution to handle all the high performance workload. So a little bit about the roadmap. Currently, we have just released our first release. So basically, it's we offer the job management, And in the following releases, we want to deliver queue management and hierarchical queue, and also the priority and the preemption and the reclaim between the jobs. And also we want to do some end-to-end enhancement and the performance optimization, including the runtime. And also we want to take the self-demand resource like accelerator and the network resource and the topology into consideration. So we are still a very young project. Definitely welcome everyone to contribute or share your idea. So here are the some of the useful resources. We have the website, and currently we also have already the first version of our code there, and also we can be found on the Twitter with Volcano SIG, and also we have the Slack channel and the mailing list. So so definitely welcome everyone to share your idea or your requirements or contribution. Yeah.
Okay. Okay. So, any question? Oh, yeah. Sorry. Queue, do you mean the current state of the queue, right? You know, we try to introduce the queue because the queue is important for batch system. Yeah, so we try to introduce a new CRD in Kubernetes because namespace or something didn't include enough information, such as the priority, plugin, scheduling policy, something like that. For now, we already have a queue. It have a weight. We also do the proportion to share resources between the different queue in KubeBatch. But you know, this is not enough. Yeah, so you know, at least there are several features in the queue. Now, the first one is we try to support a hierarchical queue. Yeah, so the queue the structure of the queue can map to your department. Yeah, you can share resources. And there are also some other requirement is that different queue, the job in different queue may require a different policy to do the scheduling, right? For example, some queue is try to schedule job by the priority. Another queue maybe try to share resource by the DRF or maybe some other policy. We try to also support such kind of feature. Yeah. Another one is, you know, we have a fair share feature, right, to cross namespace, and we also need to support fair share for the namespace cross the queue. For example, if one namespace or one user try to submit lots of job in different queue, we need to share resource to make sure these two namespaces share resource across the queue. This is also in the progress. We are trying to do that. Anyway, and another policy is that, you know, for the queue we only support weight. That means we share resource by proportion, right? But in some case, user would like to support priority. For example, high priority means all the job in the queue have a higher priority to have more resource here. We are going to support more and more feature based on the queue. But anyway, right now we have really basic feature of queue in Volcano. We are going to continue to enhance this part. Yeah. Okay. Any other question? Okay. Okay. Compared to the new code base? KubeBatch is a new code base from scratch. Yeah, so there's a total different with the default scheduler. Because in default scheduler, it do the scheduling pod by pod. Yeah, so it allows the concept about the job. For example, to run MPI job, we need to run them start together, such as gun scheduling. We need to have such kind of information in the scheduler. Yeah, so before the scheduling framework, KubeBatch is already there, so we started them from scratch. So in the next step, we try to combine them together based on the scheduling framework. But we already have something there, so there's a really long journey for us to combine the two scheduler. Yes, but I think this is in our plan for this part. Okay. Any other question? Yeah, no. Okay, thank you. Yeah.
Thank you.
Thank you.